Hello, hello, and welcome back to Solving Problems till GN, Day 3. This third installment took a very long time to to upload. Even though the problem we're gonna solve today is super simple, uh, I'm planning on continuing the series, but I don't know. We'll see how it'll work out. Anyways, for today's problem, we have a sequence an that satisfies a m plus n plus a m minus n equals 1 half a 2m plus a 2n, with m and n, of course, natural numbers, 0 included, and m is greater or equal n. Given that a1 equals 1, we should determine a of 1995. Okay, so first thing is we do some substitutions. So we replace m and n by 0, 0, which gives us by this formula that a0 plus a0 equals 1 half a0 plus a0. So 2a0 equals a0, which implies that a0 equals 0. So now we have the value of a0, which is good, and the value of a1, which is 1 by the statement, the problem statement. And then we replace n by 0, and it gives us a2m equals 4 a.m. 4 a.m. That's the time I slept, like the time when I slept today. I slept at 4 a.m., which is late because kids should sleep early. Anyways, I think if you go back and substitute n by 0, it should be obvious why we have this identity right here. It's equality. A2m equals 4 a.m. And then when we replace n another time, this time by 1, not 0, we get a recurrence relationship, which is am plus 1 equals 2am minus am minus 1 plus 2. This recurrence can give us all the values of the sequence, all the terms. So if we want a2, we just take m equals 1. So a2 equals 2a1, which is 1, minus a0, which is 0, plus 2. So we can conclude that a2 equals 4, and so on and so forth. So this recurrence that we got here in the third line shows that the sequence is uniquely determined by a0 equals 0 and a1 equals 1. So and if we calculate the first term, I think if you saw that a2 equals 4, and if you calculated a3, you'll find 9, a4 is 16, and a5 is 25. So there is a very prominent candidate as a solution for this sequence, which is an equals n squared. And when we replace it, like in the first formula that we had in the problem statement, we find that effectively an equals n squared satisfies that first recurrence relationship. And because we have this, and the sequence is determined by a0 and a1, that we have their values, that means that an equals n squared is the unique solution. Just think about it a little. I don't know how to explain it. I suck at explaining. Paquero. And so let's not forget like what the problem wants. It wants the values that can take A of 1995. And so it is 1995 squares, which computes to 3,980,024, which is the answer of our solution. QED. Okay, that's it for today's problem. Subscribe for more mediocre low effort math videos. See you tomorrow or next month.